Excuse me, doctor.
අයි මොකක්ද අසනීපය?
මගේ හිතට හරීම බයයි. ඉංග්ලිෂ් මීඩියම් සයන්ස් ෆේල් වෙන මට්ටමක් තියන්නේ ඒකයි ආවේ ඩොක්ටර්.
ඕකට බෙහෙත්වත් විසඳුම්වත් තියෙන මන් ළඟ නෙවෙයි. ඕකට ඔයා යන්න ඕන සහන් ඒකනායක සර්ගේ කිංඩම් ඔෆ් සයන්ස් ඇකඩමි එකට. ලංකාවේ ප්‍රසිද්ධ රජයේ පාසලක අවුරුදු 13ක ඉගෙන්වීම් පළපුරුද්ද ඇති සහන් ඒකනායක සර්ගේ ඔන්ලයින් මාර්ගය ඔස්සේ කරන 6 month fast track program එක තමයි ඔයාගේ විසඳුම. ගෙදර ඉඳන්ම සයන්ස් ගොඩ දාගන්න. දැන්ම මේ නම්බර් එකට කතා කරන්න.
Hello children, today we are going to discuss about grade 11 electronics lesson part 2. It may be that part 1 discuss කරලා ඉවරයි. Right, let's see. First on, we already discussed about the conductors. Conductors mean the material that conduct electricity, and also we discussed about the materials that do not conduct electricity. We call it insulators. And conductors as well as semiconductors, right? මේක තමයි අපේ බේස් එක. මේ lesson එක ඉස්සරහට සම්පූර්ණයෙන්ම යන්නේ semiconductors මත. Right, some materials conduct a small amount of electricity. We call it semiconductors, right? So when we consider about the semiconductors, these semiconductors contain some bonds. These bonds are rather weak and can be broken from the thermal energy available even at the room temperature, releasing some electrons. In here you can see special feature of silicon at 0 degrees of Kelvin. 0 Kelvin. And here you can see some covalent bonds and valence electrons. But silicon lattice at temperature above 0 Kelvin, we can see some electrons, right? Some electrons remove, then make some holes, right? Some are holes hadana gaman electrons remove වෙනවා. So semiconductors, electrons act as a negative charge of carriers as well as some holes act as a positive charge carriers. Right, then we discuss about some important points. Intrinsic semiconductors, P types and also N types. Right, last week we discussed about up to this point. Therefore some semiconductors like this electrical neutral. Right, then today we are going to discuss about intrinsic semiconductors. Right, subtopic intrinsic semiconductors. Right, pure semiconductors materials such as silicon and germanium that are exist as crystalline forms of mentioned above are known as intrinsic semiconductors. Right, pure conductors, as example silicon and germanium, we call it intrinsic semiconductors. Intrinsic semiconductors, got it? Intrinsic semiconductors. Right, semiconductors again can be divided into two parts: intrinsic semiconductors as well as extrinsic semiconductors. Okay, right, then now we are going to discuss about effect of temperature on the conduction of electricity. Right, listen to me. Right, in this graph we can see this axis resistance as well as this axis temperature. Right, temperature ka increase karanna in here you can see what happened to the conductor. Conductors wala resistance එක වැඩි වෙනවා. Got it? Resistance එක වැඩි වෙනවා. So current එක අඩු වෙන්න ඕන. Got it? When we consider about conductors, when we increase the temperature, in here you can see the resistance of the conductor is increased, resistance එක වැඩි වෙනවා. So definitely current එක down වෙනවා. Got it? But when we consider about semiconductors, in here you can see what happened. When we supply temperature to the semiconductors, temperature increase when what happened? Resistance value එක drop වෙනවා. Resistance එක drop වෙනවා. So what happened to the current? Current එක increase වෙනවා. Right? Conductors and semiconductors opposite manner. Opposite එකක් තමයි පෙන්වන්නේ. Got it? Right. Since the random motion of free electron increases, the temperature is increased. A rise in the temperature inhibits the current flow. Therefore, temperature rise in conductors cause decrease the conductivity. Right. Decrease the conductivity mean increase its resistivity. But when we consider about semiconductors, a rise in the temperature break bonds generating more holes and free electrons. More holes mean positive charges. Electrons negative charges. So when we supply heat to the semiconductors, breaks bonds generating more holes and free electrons. Therefore increase the conductivity. Increase the conductivity, right? මෙන්න මේ point එක MCQ questions වල වගේ ගොඩක් කලාවට touch කරා. Right. Is it clear? Okay. Good. Right. Now we are going to discuss about extrinsic semiconductors. Extrinsic semiconductors ඔන්න දැන් ටික ටික advance වෙනවා. Right? ටික ටික ඔන්න advance වෙගෙන එන්නේ. Okay? Right, we'll see. Right. Let us consider what happened when a minute amount of element phosphorus is mixed. Right? Mix කියනකොට ඔන්න additional name එකක් කියනවා electronics වල doped to an intrinsic semiconductor such as silicon. Right. Now we are going to discuss about extrinsic semiconductors. No, right. On silicon. When we consider about silicon වල outermost shell එකේ only 4 electrons. We last week discuss kara. Is it clear? Right. දැන් additionally කරන්න යන්නේ dope කරනවා phosphorus වගේ element එකක්. Phosphorus mean group number 5 වල ඉන්නේ. Group number 5. Right? Periodic table එකේ phosphorus in group number 5. So how many electrons are there in the outermost shell? 5 electrons. On 5 electrons there. Got it? Right. On the silicon whenever replace karno phosphorus. Phosphorus. Got it? Right. First one, first electron, second electrons, third electrons, fourth one. Right. In here you can see there are additional electron. When additional electron. Is it clear? Additional electron. Right? First one, second one, third one, fourth one. Right. In addition on තව electron එකක් එනවා. Extra electron. Extra electron. Got it? Silicon එක combine වෙන්න පුළුවන් only 4 electrons. But when we dope phosphorus like element with the silicon atom, silicon lattice, right, on the 4 electrons join una. In addition you can see there are some extra electrons. So what happened? Right, දැන් මොකද වෙන්නේ? ඔන්න extrinsic semiconductors වලට phosphorus rephrase කරාම තව additional electron එකක් එනවා. Got it? Right, let's see. A phosphorus atom forms bond with silicon atoms. On a phosphorus silicon atoms එක combine වෙනවා. The electron left behind increases the conductivity of lattice. So negatively charged electrons are introduced to the lattice as charge carriers the semiconductor is known as negative right types. ඔන්න බලන්න. Listen to me. Right. දැන් extra electron එකක් තියෙනවා. So extra electron negative charge. Negative mean negative charge. So negative. Right. Negative type nisa we call it short form N type. N type. So we call it N type extrinsic semiconductors. Right. Got it? Right. Is it okay? Right. Again on the balance. When we consider about silicon atoms, there are 4 electrons in the outermost shell. But when we mixed phosphorus like element with the silicon atoms, on the balance phosphorus wala group number 5. So outermost shell එකේ 5 electrons. On a silicon එක combined වෙනවා 4ක්. In additionally one extra එකෙනෙක් එනවා. Right. So extra electron එක negative type. Negative type mean we call it N type extrinsic semiconductors. Is it okay? Right. ඔන්න එහෙනම් N type conductors, semiconductors හදන්නේ phosphorus. That means group number 5 වල ඉන්න element එකක්. Is it clear? Right. Good. Let's see. Right. Extrinsic semiconductors. Semiconductors whose carriers have been increased by doping it with another element are known as extrinsic semiconductors. Right. Semiconductors වලට semiconductors whose carriers have been increased by doping with another element. තව element එකක් එකතු කරලා conductivity value එක වැඩි කරනවා නම් we call it extrinsic semiconductors. Right? Extrinsic semiconductors, there are 2 types. First one N type, we call it negative type, and P type mean positive. Got it? Right. By doping an intrinsic semiconductors with other elements. Right? Intrinsic semiconductors now pure වෙන්න ඕන. Right? Pure mean silicon or only germanium. But extrinsic semiconductors mean on අපි additionally තව electrons N type hari negative type hari collect කරනවා. Right? By doping an intrinsic semiconductors with other elements in group number 5. Right? Group number 5 වල එක්කෙනෙක් ගත්තොත්. As an example, arsenic, second one, antimony, Sb, antimony, or phosphorus. Also known as N-type extrinsic semiconductors. Right? On a group number 4 වල arsenic, antimony, or phosphorus. Got it? Arsenic, antimony, or phosphorus. මේ කෙනෙක් join වුණොත් N-type extrinsic semiconductor එකක් හදන්න පුළුවන්. N-type. Right. Since electrons are denoted the lattice by group 5 elements, they are known as donor atoms. On MCQ questions වල අහන්න පුළුවන්. Donor atoms නම් group number 5. In here you can see there are three examples: arsenic, antimony, and phosphorus. Right? Arsenic, antimony, and phosphorus. Got it? Arsenic, antimony, and phosphorus. Right. Next one. Now we are going to discuss about p-type. P-type mean positive. P-type mean positive. Positive. Positive type. Got it? Right. P-type mean positive type. Right. Positive type. Now listen to me. Right. Positive nang number of holes gana වැඩි වෙන්න ඕන. Right. Number of holes gana වැඩි වෙන්න ඕන. Is it clear? Right. Holes gana වැඩි වෙන්න නම් කීවෙනි group එකේ elements ද mix කරන්න ඕනේ? Yes. Yes. Group number 3. Group number 3. Right. Now listen to me. If silicon, which is an intrinsic semiconductor, is doped with an element of group number 3, such as boron. On the group number 3 වල අපි කවුද example එකට ගන්නේ? Boron. The boron atom forms bonds with nearby silicon atoms. Right. Now listen to me. Right. Now listen to me. Right. Borons. When we consider about boron, hydrogen, helium, lithium, beryllium, boron. So electronic configuration එක 2,3. 2,3. Right. In here you can see on a 3 electrons. Outermost shell එකේ only 3. So first one, second one, and third one. Right. But in here holes. On a hole එකක් හැදුණා. Holes. Right. Holes. Positive charges. So positive mean p-type. P-types. Positive mean p-types. Got it? දැක්කද හැදුණු හැටි? Right. Negative නම් group number 5. Arsenic, antimony, phosphorus. But when we consider about p-type, that means positive type, so group number 3. Right? On the boron. Right. A hole exists at the point where the electron is deficient, the boron atom to form a bond. Since holes can conduct electricity as a positive charges. On may holes positive charges විදිහට current එක අරන් යන්න පුළුවන්. So holes can conduct electricity as a positive charges. The conductivity of silicon is increases. So normally in a silicon වලට වඩා positive charges holes වලින් can conduct electricity. Got it? As the holes is equivalent to the positive charge, such extrinsic semiconductors are known as positive or p-type semiconductors. Right? Positive or p-type semiconductors. Positive or p-type semiconductors. Right. Got it? Very good. So let's see. Because of the holes concentration in p-type semiconductors in much greater than the electrons concentration, holes are called majority carriers and electrons are called minority carriers. So by doping an intrinsic semiconductors with other elements in group number 3, on group number 3 එකේ, right, what are the examples? Boron, okay, aluminium, okay, then gallium, Ga, gallium, okay, and indium, Ia. Instead of boron also p-type. Right. On a p-type semiconductors හදන්න පුළුවන් boron, aluminium, gallium, and indium. Gallium and indium. Right. Group number 5. Group number 5 කවුද උනේ? Arsenic, antimony, and phosphorus. Arsenic, antimony, and phosphorus. arsenic, antimony and phosphorus. Right? Group number 3 wala boron, aluminium, gallium and indium. Got it? Right. Since holes that can receive electrons are produced by group number 3 elements, they are known as acceptor atoms. Right. On acceptor atoms කිව්වොත් boron, aluminium, gallium and indium. Right. ඔන්න දැන් ඉස්සරහට paper class වල right electronic resonance එකේ questions දැම්ම පටන් ගන්න. Right. ගිය අවුරුද්දෙත් structured essayවත් essayවත් ආවේ නැහැ. So එපාර probability එක වැඩි. Right. essay question no structured එකකට එන්න. Let's see. Right. On a very important part. on අද යන important දේ හරි ඊළඟ දවසේ තමයි transistors ගැන අපි discuss කරන්නේ. Next week එකේ transistors වලට base එක තමයි PN junctions. Right. Now listen to me. One nice simply. Right. P means positive. P mean positive. So N mean negative. Okay. Positive නම් number of holes. ඔන්න holes ගාන වැඩි වෙන්න ඕන. Electrons නම් negative. Right. Number of holes වෙන්න නම් group number 3 වල. That mean boron, aluminium, gallium, indium. But when we consider about N negative type, group number 5. What are the examples? Phosphorus, antimony, gallium, germanium, phosphorus, arsenic, antimony, right? One example, right? Then කරන්න යන්නේ P type and N type extrinsic semiconductors දෙකක් එක ළඟ තියෙනවා. So on the PN junction එක හදන්නේ මේ method එකකින්. Right. Now let's see. By doping one side of an extrinsic semiconductor such as silicon or germanium with group number 3. On silicon or germanium with group number 3 to form P type. On a P type. Group number 3 now we call it P type. Semiconductors and other side with group number 5. So silicon and germanium with group number 5. With group number 5. Group number 5. So we call it N type. We call it N type. 4 elements to form an N-type semiconductors. N-type semiconductors. A PN junction can be formed at center of the semiconductors. Right. Now listen to me. ඔන්න බලන්න කතාව. Right. P-type නම් positive. Is it okay? P-type mean positive. N-type mean negative. So P-type නම් positive. E-type non negative. Is it clear? Ek okay the? Is it clear? Right? So positives nang number of holes තියෙනවා 1 2 3 4 5 6 7 8. When we consider about N type, free electrons තියෙනවා 1 2 3 4 5 6 7 8. Right? Now listen to me. PN junction. Right? Number of holes on the positive. Positive, that means P type. So number of electrons 1 2 3 4 5 6 7 8 9. So negative type, so we call it N type. Right. Now listen to me. පුතේ holes positive charges. When we consider about electrons negative charges. Right. මේ දෙක මොකද වෙන්නේ? එක ළඟ තිබ්බ ගම. Yes. In here you can see what happened. මොකද වෙන්නේ? nen types ටික එනවා මේ side එකට positive ටික යනවා මේ පැත්ත. ඔන්න පළවෙනි layer එක දෙවෙනි layer එක වගේ ඉන්න කට්ටිය mix වෙනවා. Right? Holes වලින් positive charges මේ side එකට යනවා negative charges මේ side එකට. So we call it depletion region. Got it? Right? Positive type එකේ ඉන්න holes n type එකේ ඉන්න free electrons දෙක එකට set වෙනවා. set වුණු ගමන් මේ දෙක change වෙනවා. ඒ change වෙන region එකට අපි කියනවා we call it depletion region. Depletion region. Got it? We call it depletion region. So p-type holes වල negative charges, negative type electrons වල positive charge. Okay? Right. On a name karan. p-n junction. By doping one side of an intrinsic semiconductors such as silicon or germanium with group number 3 elements to form p-type as well as other side with group number 5 elements form an n-type semiconductors. Right. Note එක හරිද? Okay. Right. Let's see. Right. p-n junction is formed in the free electrons in the negative region diffuse across the junction towards the p region and holes are p region diffuse towards the n junction region. Due to this diffusion, electrons and holes recombine forming a region devoid and charges near the junction. Right. As an example, we discuss kara on the holes 1 2 3 1 2 3 4 on the 12th, you know, right? On the electrons 1 2 4 1 2 3 4 1 2 3 4 in the holes positive charges positive on the holes positive. Right. Then what happened? Electrons negative. Right. On a p path p side then n side. Right. එක ළඟ තිබුණු ගමන් මෙන්න මේ ටික මොකද වෙන්නේ? positive charges ටික මේ side එකට negative charges this side. ඔන්න මේ වෙනවා diffuse වෙනවා. We call it diffusion. Right. After the diffusion මෙන්න මේ වගේ එකක් බලන්න පුළුවන්. positive plus and then negative on the main side දෙකෙත් negative 3. Right. So we call it මෙන්න මේක තමයි diffusion වෙන region එක. Depletion region. Right? Got it? Right. Good. Right. මේ figure එක තියෙන්න ඕනේ and this one. Right. Let's see. Right. Potential barrier. Right. ඔන්න දැන් තමයි ටික ටික advanced part එකට එන්නේ. Right? Listen to me. The potential difference repels the charge carriers impedance of diffusion charge carries across the junction. Therefore, this potential difference is known as potential difference repel the charges. Right, listen to me. Right. When we consider about PN junction, P side and N side. Right. On the depletion region right. We call it depletion region. Right. Okay. On my depletion region potential barrier එකක් විදිහට ක්‍රියා වෙනවා. It is act as a potential barrier. Right. මෙන්න මේ potential barrier එකේ තියෙන voltage එක right ඔයාගේ ඔළුවේ තියෙන්න ඕනේ. මොන transistors වලට base එක හදලා තැන. Right. මේ තියෙන depletion region එකේ potential barrier එකක් විදිහට ක්‍රියා වෙනවා. It is act as a potential barrier. This potential difference repels the charge carries impedance. Diffusion of charge carries across the junction. Therefore, this potential difference is known as potential barriers. Right, Mehan. Now listen to me. The potential barrier represented in the above figure is hypothetical battery. Right? මෙන්න මේ diffusion region එක battery එකක් විදිහට act කරනවා. It is act as a battery. Right. ඔයා මේව මතක තියාගෙන ඉන්න. Points දෙකයි ඕනි. Silicon වලින් නම් හදන PN junction එක. Right? Silicon වලින් නම් මේ PN junction එක එන්නේ. Right? 0.7 volt. 0.7 volt. Germanium නම් 0.3 volt. Got it? 0.3 volt. Right? Potential barrier එකේ number එක ඔළුවේ තියෙන්න ඕනේ. Keep on your mind. Is it okay? Right. When we make silicon PN junction, this potential barrier equals 0.7 volt. When we number keep on your mind. 0.7 volt. If we take germanium, this value will equal 0.3 volt. Got it? 0.3 volt. Right. Okay. Then very important part. On the May part again. Right. So in here you can see basing a PN junction. Right, basing. Right. Now listen to me. Right. In this figure we can see the P type and N type. On a P type so positive. P type mean positive. N type mean negatives. So P type positives nang number of holes gana වැඩි වෙන්න ඕන. N type mean electrons gana වැඩි වෙන්න ඕන. Got it? Right. So basing means now listen to me. Right. PN. Right. Basings now external potential difference like a battery එකක් වගේ voltage difference එකක් externally මෙයාට දෙනවා. Right. ඔන්න externally මෙයාට දෙනවා. Right. Right. Then now listen to me. ඔන්න බලන්න. Right. විනාඩි දෙකකින් ඉවරයි. Right. Easier. Right. So on a negative terminal, this one we call it positive terminal. Got it? Right. P type nang number of holes තියෙන්නේ. N mean electrons. Got it? So electrons negative type, holes positive type. Then what happened? In here you can see 1.5 voltage. Right? So plus. Then negative electrons attract towards the positive terminal. Attract towards the positive terminal. Then what happened here? Positive type holes attract towards the negative terminal. Attract towards the negative terminal. So the narrow depletion region, මෙන්න මේ depletion region එක, right? මේ දෙපැත්ත ඈත් වෙනවා. So what happened? Depletion region එක increase වෙනවා. Increase වෙනවා. Got it? Depletion region එක increase වෙනවා. Right. Got it? Right. Then listen to me. Right. Again, PN junction, right. External voltage difference, external voltage එකක් දෙනවා, positive, negative. So P mean positive number of holes, then negative electrons. Right. Then what happened? Positive charges holes, and here also positive. Positive. Attract or repel? Yes, repel. So මේ side එකට එනවා. And here also negative charge electrons, and here also negative electron, negative terminals. Then again repel. So what happened to the depletion region? Depletion region එකේ size එක, thickness එක අඩු වෙනවා. Got it? Right. We call it ඔන්න ඔය technique එක තමයි forward bias or reverse bias කියලා අපි discuss කරා. So basing mean external potential difference එකක් supply කරන්න ඕනේ. Right? Potential difference එක PN junction එකට mesh කරන විදිහ අනුව forward bias or reverse bias කියලා discuss කරමු. Got it? Forward bias or reverse bias. Is it clear? Right. Let's see one by one. In this case, the external potential source is connected with the positive potential connected to the P region. Right. Now listen to me. Right. P N. Right. P and N. Right. In this case, external potential source is connected with the positive potential connected to the P region. Right. P region negative positive. Then N region negative negative. Negative positive. Right. Potential source is connected with the positive potential connected to the P region. Positive P, and negative terminal connect to the N region. Then what happened? While the holes in the P region are repelled, so repelled, the positive potential towards the junction and electrons in the N region are repelled by the negative potential towards the junction. On the junction එකට දෙකම repel, and repel. Right. Note down Karan. Note down Karan. Clear? Right. Let's see. So let's see. Right. reverse bias. Right. Forward bias now P ekata positive, N ekata negative. Right. Then reverse bias. Reverse bias. Right. N type, P type. N type now positive, P type now negative. So depletion N type now negative attract towards the positive charges. Positive charges holes attract towards the negative terminal. Then what happened to the depletion region with increase? Depletion with increased. Depletion with increased. Depletion with increase. Right. මෙන්න මේ figure එක දෙන්න. PN junction. Right. අපේ figure එකට මෙයා PN junction negative positive negative and positive negative positive positive negative. Then what happened? Positive charges holes attract to the negative terminal. Negative charge electron attracts towards the positive terminal. Then what happened to the depletion region with increased? With the increase. So we call it reverse bias. Reverse bias. Reverse bias now P side negative, N side with positive. N side with positive. Got it? Right. Is it clear? Good. Right. Let's see. In this case, free electrons in the N region are attract to the positive potential. Right. NP. Negative attract towards the positive charges. Positive attract towards the negative. While the holes are attract towards the negative. Holes are attract to the negative. So broadening the depletion layer, there is no carriers for few across the junction. Only the depletion region broadens depending on the potential difference of external source. There are so no charge flows connecting with the external potential is manner is known as reverse bias. Right, on the reverse bias. Right, forward bias and reverse bias. Forward bias and reverse bias. Is it clear? Right. Then PN junction diodes. Right. Very important part. Right. Right. මෙන්න මේ PN junction එක use කරලා අපි හදනවා diode එකක්. Right. Diode. This is the symbol. Right. So positive terminal, negative terminal. We call it anode and cathode. Anode and cathode. Right. Anode and cathode. Is it clear? Right. PN junction diode, positive terminal and negative terminal. Right. Now listen to me. Right. On the practical එක. Right. On the external voltage එකක් supply කරනවා. Right. On a bulb එකකුත් දෙමු. Bulb. Right. Now listen to me. Right. Positive charge, negative charge. Right. What happened to the current? Positive to negative. Right. On a diode එක through වෙනවා. Then what happened? Bulb එක through යනවා. Then what happened? Yes. Bulb is lights up. Bulb එක okay. Right. එහෙනම් මෙන්න on. Switch එක on. Switch එක on. Right. Let's see. Right. Positive, negative external bulb, right? Then what happened? Negative, positive, negative and positive, right? On the current flow එක එනවා, bulb through එනවා, right? Negative, positive, right? Diode එකේ මෙන්න මේ negative side එක set වෙනවා නම් current flow එකක් එන්නේ නැහැ. It's very important, right? Current flow එකක් එන්නේ නැහැ. Then what is the observation? Bulb එක light up වෙනවද? No. Bulb එක light up වෙන්නේ නැහැ. Right. Bulb එක light up වෙන්නේ නැහැ. Okay. So this is we call PN junction diodes. Right. මෙන්න මේ figures දෙක ඕනි. On and off. On and off. Right. Figures දෙක mention කරන්න. PN junction diode. Finish. Okay, right. Next week on අපි discuss කරමු about the transistors, right? Transistors ගැන discuss කරමු next week එකේ. ඔන්න PN junction, P type, N type, PN junction and PN junction diodes වලට එනකන් ඔන්න දැන් one by one discuss කරන් ආවා, right? මේ වෙද්දී ඔයාලට theory tube එක හම්බෙලා ඇති, right? theory tube එක fill කරන්න. එහෙම නැත්නම් ඔන්න තවත් හම්බෙච්ච දෙයක් ඉන්නවා නම් අපෙන් ඉල්ලන්න. Right? Okay. Right. Thank you. Let's sign up today.